Two scientists walk into a bar. The first is named NULL, and the second is named ALT. The two walk up to the bar itself, and the bartender asks, "What'll it be?" NULL says, "I bet that if you drink the beer here, that nothing will happen." To which ALT replies, "I bet the beer here will get you pretty drunk." The two scientists drink long into the night until NULL blacks out, and, because he passed out, was rejected by the bar patrons and thrown out into the dumpster. This is a bizarre, but easy to visualize example of how one remembers what a hypothesis is and how they're tested. A null hypothesis is typically the standard assumption and is defined as the prediction that there is no interaction between the variables. The symbol for the null hypothesis is a capital H with a subscript O. This is opposed by the alternative hypothesis, also known as the research hypothesis, defined as the prediction that there is a measurable interaction between the variables. The symbol for the alternative hypothesis is a capital H and a subscript 1. When we're testing our hypothesis, we will run a statistical procedure to determine if there is a significant relationship. Statistically significant means the difference in the results did not occur by random chance. This is almost always represented by a lowercase p. Another term you may also hear for this is alpha, and may be represented by the alpha symbol, the one that looks like a little fish. What a p-value tells you is the percentage that the results are caused by random chance. If you have a p-value of 0.75, that means the numbers were so close that any difference is likely to occur 3 times out of 4. In psychology, an experiment seen as statistically significant has a p-value of less than 0.05. Often when writing up the results of an experiment, you will use the phrase statistically significant or not statistically significant. This lets you know whether or not the experiment demonstrated a difference, relationship, or interaction. This is at the heart of the hypothesis testing. There are dozens of statistical tests to run, and nearly all of them have a statistically significant component to let you know if the differences are viable. But you aren't done here. When your numbers demonstrate an interaction, this means you need to report it in the correct way. After testing a hypothesis like, "Will you get drunk?" you will assume that the null hypothesis is true, but the testing is to see if your alternative hypothesis is accurate. Now, this is where things get a little complicated because the language of an experiment shifts from everyday vernacular. If you do not find a difference between the variables, or we could say that you did not demonstrate your alternative hypothesis as correct, then we say the results were not statistically significant, and therefore the experiment failed to reject the null hypothesis. This means that you were unable to demonstrate a significant interaction or relationship. Therefore, you were unable to reject the base assumption that there is no relationship. You can think of it like there not being a connection between the variables. If you do find that there is a difference between the variables, that your statistics found significance, you would write the results were statistically significant, and therefore the experiment rejects the null hypothesis. In scientific literature, you reject or fail to reject the null hypothesis. This has to do with the language of mathematics. The statistical significance demonstrated that there was a difference between the variables, and in math, one either rejects or fails to reject instead of accepts. It's kind of confusing, so most researchers just learn it by rote. In hypothesis testing, you focus on 2 hypotheses. The null hypothesis is defined as the prediction that there is no interaction between variables. This is opposed by the alternative hypothesis and is defined as the prediction that there is a measurable interaction between the variables. When testing for statistical significance, you want below a 0.05 p-value. If you do have below a 0.05, you are able to reject the null hypothesis. If your p-value is above 0.05, then you fail to reject the null hypothesis.